Get started with our afternoon Ag Talk, at least the first one of two here today. Good afternoon. Thanks for being here, by the way. My name is Chad Moyer. I'm a farm broadcaster with KTIC Radio and the Rural Radio Network. We are the only farmer-owned group of radio stations in the state, cooperatively owned. We run 14 stations across the state and then a statewide network as well. I've been with the company going on 17 years, so happy to serve agriculture in that regard. In our panelists today, we are going to talk about autonomous machines and what that might mean to the future of agriculture. And we have four individuals who are experts on stage here today. I'm just going to quickly introduce them. First here, Dave Krog. He's with Salin 24/7. Troy Fletcher is next. Troy's with Rogo Ag. Craig Rupp is in the third position. He is with Sabanto Ag. And then on the end is Brent from Stout Ag. And again, been very active in this space. That's why they asked them here, so that you can learn from them, listen to them, and ask questions and challenge them on some of these new opportunities in agriculture. So again, thank you for being here today. Panel, thank you for taking the time and being a part of this discussion. I think we're just going to we'll start here close and go down the road, just get a little bit of background about you and the company that you've started, how you kind of got into this. So let's start with Dave with Salin 24/7. Go ahead, introduce yourself, tell us a little about you and your company.
All right, Chad, it's great to be here. So my name's Dave Krog. I'm with Salin 24/7. We're based in Ames, Iowa. We've been in business 2 years now, so we are a startup. And we're focused on small-scale, lightweight, autonomous, electric-powered farm equipment. So the idea is to address some of the soil compaction and other soil health issues that we have and get big, heavy equipment off the field and replace it with small equipment without giving up capacity to get acres covered. So instead of big equipment, you might have multiple pieces of small equipment. And when you go to small, it makes sense to go to autonomous because it's hard to get operators. And so, yeah, that's where we're at today.
Okay. So tell me about why did you choose that pathway? Smaller, electric, things like that. What was happening that you saw that was the solution to the problem out there? You know what I mean? Why did you choose that path?
Yeah, so I grew up on a farm in Iowa, and over the years we always dealt with soil compaction problems, but we just dealt with it. We didn't really do anything about it other than we did some tillage to try to alleviate some of the surface compaction, but we just felt that it was something we had to live with. So later on in life, and farm machinery kept getting bigger, so the problem kept getting bigger on our farm. And it just kind of occurred to me that, why are we living with this? Why don't we do something about it? And so what do you do? So, university folks and experts talk about just don't go out on the field with big heavy equipment when it's wet, but that's easier said than done. And so, what's the alternative? Well, our thinking was, get the big heavy equipment off the field and replace it with lighter weight equipment. So it was really to focus on soil compaction, but our vision is broader than that, because there's other things you can do, unique things you can do with small equipment as well that you might not be able to do with large equipment. So we have a focus on soil health and sustainability in general.
Very good. Good to have you here. Troy with Rogo Ag. Again, a little bit of background about you, and tell us about Rogo Ag. What are some of the things that you're working on?
Yeah, so I have a background in farming. We still farm in Indiana. It's a large commercial operation, and I was managing the fertility side of our business coming out of college as an engineer, and I recognized that our fertility side was still our third highest cost, even though I thought we had a pretty good strategy of reducing that. And I remember I think I was telling you this yesterday, but I was spreading chicken litter once, and I just looked over at the guy soil sampling our field across the road, and I was just thinking, man, that is just not, why is that just not automated? And as I started researching, how much our fertility results can change based on how it's soil sampled, I realized that oftentimes, if you compare a hand sampler to a perfect probe, what's actually happening in real life versus what should happen, oftentimes they agree, but oftentimes they don't. And like more than 30% of the time, they very much disagree. And so I was worried about having artificial VRT maps on our farm for fertilizer. And so there was an injustice in my heart to solve that problem. And I've made many prototypes. We started the company in 2019 after the fourth prototype. And we've even made revisions to our robots 3 times since then. We are on our last one. We have a robot that we're scaling up now. And we've been able to go through the retailers to provide this service to the farmers, and that's been a really good fit because our goal is to make the retailer look good. I want them to be the hero. They know the farmers the best. They're a scalable solution, and it's important to them. Soil sampling is kind of out of sight, out of mind until it's not. It's like a necessary evil, and no one really cares about it until it's not there. And so we've had a focus as a company, really full circle business on how to deliver technology that's solving a real problem, how to deliver that solution into the marketplace in a way that they care about, and then we have a customer service. Like we have customers, we're serving people, we're building robots, we're operating them ourselves, and it's been a really neat journey. Yeah, growing like crazy, so it's been fun.
Excellent. So Troy, tell me, what was the most difficult going from model number 1, machine number 1, to something that you feel is scalable? What was the most difficult part of that journey?
I think confronting truth in my life. You can get, as an engineer who's trying to solve a problem, you can get pretty romantic about what solutions are needed to solve that problem. And I think that can be I think we have to surround ourselves with people that are telling us, well, let's start here and let's focus on solving that problem. So for example, I built 4 fully autonomous machines and we sampled 200,000 acres with those machines, 4 machines. And we were proving that we could get a lot of work done. Like in a fall season, one machine was able to sample 25,000 acres and no engineers are running them. But after the 100,000 acre mark, I started running some problems with my packaging system, and mainly the packaging system. and so I was like, man, I'm paying these guys to sit at the edge of the field anyway. And so in 2020, we said, all right, let's get rid of the romantic side of things and let's scale down one notch and go semi-autonomous. So we put the guy back in the machine, focused solely on the soil collection side, said the guy can bag up the soil just fine. Let's start there and then let's progress from there. So that was a humbling part of the journey.
So you were going full scale this way. You recognized the need to back up a step so that you could move on further, huh?
Yeah, and I think that was, we already had customers at that time. So we knew we were solving a real problem, but we didn't want to get the cart in front of the horse. So we had to communicate that, and it all went well, but it was a scary moment. It was a scary time. A lot of learning.
Absolutely. Craig, with Sabanto, tell us a little bit about you, your background, and what are you focusing on?
Okay. First and foremost, thank you for having me here. Go Huskers. I'll start by, I grew up on a farm in northwest Iowa. Corn, soybeans, hogs, cattle. I thought I was cursed, and when I graduated high school, the last thing in the world I ever wanted to do was set foot on a farm again. Went and became an electrical engineer, and I worked primarily my career, I spent about 20 years in the wireless industry, primarily cellular. That little device you carry around with you, I probably had a hand in it, working for all the companies in the cellular industry. I did a lot of automation, factory automation, for a lot of these cellular companies. Spent a lot of time in China working at them. But given that my background, I kept getting pulled back into agriculture. I did do a stint at John Deere, worked on the Starfire receiver and Green Star display. And then I started a company called 640 Labs, the FieldView Drive, little device you plug into your tractor. I was the guy behind that. I started that company, and then it got acquired by Monsanto, and I was put underneath Climate Corporation. I spent a lot of times with farmers, and I just got to understand some of the problems they're having. Number one, labor, and number two, I just couldn't believe how much capital these guys spend for tractors that they put 300, 400 hours a year on them. And I knew autonomy. I believe autonomy is going to be a mainstay in agriculture. So I quit my perfectly great paying job, and I went and leased a JCB 4220 tractor, and I went and bought a planter, an 18-row, 20-inch planter, threw it on the back of a semi, got a CDL, spent a lot of winter writing software, and I went out in 2019 and started trying to understand just what autonomy in agriculture means. I hired a team of an initial 6 engineers, and then the first thing we did was we went smaller. It's my mindset, my belief that we peaked in horsepower. Autonomy is going to increase time, which decreases horsepower requirements. So we take, we're up to 200 horsepower, but we're primarily focused on performing row crop agriculture with smaller equipment.
So I guess, again, what impact have you seen so far of that work? Is it going the way you want? Have there been pitfalls, stumbles? What do you think is what's been the most interesting part of that process with this concept, with this venture?
Yeah, in terms of pitfalls, I could spend all day telling you about some of the challenges with taking these units out in the field and trying to get them to work reliably over 24 hours. I think some of the defining moments. I have a 60 horsepower tractor that has planted 750 acres all by itself. I have multiple units that have ran 48 hours non-stop by themselves in Hastings, Nebraska. So we're starting to see just the power of autonomy and just what you can do once all the wrinkles are ironed out.
All right, we're going to dig more into that here during this too, but we would need to hear from the gentleman on the end, Brent with Stout Ag. Again, a little bit of background about you and what part of autonomous farming did you decide to focus on?
Yeah, so I'm the first generation not on the farm. My family had 1,000 acres up in Alturas, California. All of us kids decided we really weren't hip to Alturas, California, so we all took different pathways. Farm got sold. So I come out of the autonomous vehicle industry in Silicon Valley, and I didn't start Stout. I was brought in by the board about a year ago, which I thought was to make the Stout machines autonomous, and it turns out actually no. They wanted me because I've also started a number of artificial intelligence companies, and Stout is at its core an artificial intelligence company. So Stout's focus is on applying artificial intelligence in the field of agriculture to help with labor-intensive applications in the field.
This might be just a sidebar, but since you said you came from the autonomous vehicle side of things, could you talk a minute or a second or two about the trucking? I've heard that there's 80, 90,000 empty trucks, open trucking jobs right now, and I know that the research continues on tag teaming trucks or autonomous trucks. What's kind of the latest on that?
I think the latest on that is so Kodiak has been running autonomous trucks for quite a while now, long distances, autonomously, driverlessly, without safety drivers. But probably the biggest news on that is the whole Tesla delivery to Pepsi of, I think it was 50 Tesla semis that are fully electric and have the autonomous capability, but they have not started running them fully autonomous. I think there's, like I said, I come out of that space, so there is a lot of discomfort with drivers today when they see a fully autonomous vehicle on the road, whether that's a truck or whether that's a car. If you go to San Francisco today, you've got both Cruise and Waymo running fully autonomous, no safety driver vehicles through the city. They're also expanding into LA and Phoenix, I think it is, Scottsdale, something like that. So it's all coming, but it's coming slower than we all thought, but it's coming.
Very good. Well, again, panelists, thank you for being here. And again, a reminder to the crowd, if you have questions that you would like to ask, something that they said that you want to dive deeper into, ask a different question, please raise your hand, get my attention. We'll get this question, we'll get the question asked, because we want this to be interactive. We want this to be a conversation, and that you walk away with as much knowledge as you can get here in a 45-minute session. So with that, I've got a couple starter questions, so I'll kind of throw it out, and I'll throw it out to the panel. Not everyone has to necessarily answer it. I don't want to just go bang, 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 down the line back and forth. But I'm going to throw out some questions. If you feel like you'd really like to respond to that, or that's something that you have a thought or idea on, please feel free to answer that. So bringing it back to autonomy and agriculture and farming, what do you think is the real advantage of the autonomous vehicles, the autonomous equipment in agriculture, in farming today? What is the real advantage of some of this? Craig?
First and foremost, labor. Every farmer I talk to, it seems like labor is their number one issue. And it's not the cost of labor, it's just the lack of labor. And first and foremost, that is the number one problem everyone's trying to solve.
All right, so labor. Anybody, any other thoughts?
So I guess I've got kind of a counterpoint to that a little bit. I think there's so two things, right? There's Cal OSHA in California that is not actually allowing autonomous vehicles in fields today. And some of that is around labor, a lot of it is around safety. They just don't believe that all the edge cases that exist for autonomy in the field can be handled today. But I can also say that the labor issues, certainly with labor brought in from out of the country, these days you've got to provide both housing, feeding. COVID can decimate your entire human workforce. Like, it's just a really super high risk. So any technology that helps take that out of the equation has a great deal of value. So I think that definitely fits with what Craig said.
Hello. Yep. So in my situation, it's for quality control, really, and our customers could 20% of what they care about with working Rogo is that our vehicles drive themselves. It's not a big mover. They're basically transferring their labor problem to us. So how am I better at managing that soil sampling job than our customer? Well, I think it comes down to, for us, our value proposition is, and there's not many jobs left like this in agriculture, but we're taking soil samples by hand, and it's a very hard job, and when you do it wrong, it has high consequences. And so we're bringing quality into that, and some predictability. And so that's really good. But then we still have a labor problem. Well, if we make the job easier for my operators on our robots, that's a big deal, because now they can run more hours per day, they enjoy their jobs, I have less turnover. It's still not perfect, I still have turnover, but it's actually way, way less in comparison to my competitors. And then, because it's automated, now we can be more productive. An operator can get 150% more done in a fall season than they were if they even had to engage their brain more. So it's a very mentally relaxing job in comparison to our competitors. So I'm in a little bit of a unique position in the sense that I exist because there's a quality problem. But if I want to continue to exist, I got to make the job easier and faster, and for my operators as well.
What do you think about the benefits of autonomy in agriculture? What are the real benefits?
Yeah, I think, when we started our company just 2 years ago, labor really wasn't on our radar screen. We were thinking more, soil health and sustainability. But but the more we talk to farmers, the more we hear about labor. So, I've talked to different farmers that they don't necessarily have trouble getting people, but they'll say things like, I think machines can do a better job than people, including myself, with pointing at themselves. So obviously there's some things that people can do a better job than a machine, but for the most part, a lot of the field operations, I think the machines can do a better job, and clearly they can run 24 hours a day, and you don't have to worry about breaks and things like that. So I agree. I think it's a lot about productivity.
So just about your machine, when you were talking about doing farming operations, small scale, but nonetheless, these pieces of equipment have to go across different soil types and different terrains and things like that. Are you making progress in getting that work done across all of the different terrains and situations and things like that you have to accomplish farming in?
No. So we're early on. We're in the prototyping stage, and this year we were in the field. We were on 7 farms last spring planting, and we intentionally picked easy fields, so flat, relatively flat, and straight rows and things like that. We have some basics that we need to get taken care of. We know that we're going to have to figure out how to do tough terrain and challenging fields. We just haven't gotten there yet.
Sure. It's going to be a challenge at some point, right? Yeah.
We have to do it. We have to figure it out.
Yes. I know there's some guys that were from the AI world and, trying to get this machine to learn, understand what it's supposed to do, and then actually accomplish that. Somebody on the panel, would you talk about how do you teach this machine? How do you program the machine to be able to learn and accomplish what you want it to do?
That would probably be a better question for my CTO, but the easiest way to think about AI is it's like a small child, right? So we perceive the world with our eyes. AI perceives the world through machine vision, right? You need a parent next to your child saying that's a chair, that's a man, that's a woman, that's a wall. That's how the child learns, right? That's how AI learns. You have to identify what those characteristics are, what those elements are, and then once you've trained the AI to know that, then the AI gets it. But it takes time because that chair doesn't look like this chair, that person doesn't look like that person, so you've got to show the AI a lot of chairs and a lot of people before the AI understands, oh, I haven't seen that person before, but I know that it's a person because I've seen enough people to know that that's a person and not a chair, right? So that's when you're going through in the agricultural space, you're showing it a crop, and you want to show it literally thousands, tens of thousands of images of that crop in different lighting conditions, in different soil conditions, different sizes, all kinds of stuff. And then once you've trained it, now it knows it, and so now you can, now it's ready to respond to, what do you want me to do with that, right? So in our machines, the AI recognizes the environment that it's operating in, and you get to tell it what you want it to do. So if you're telling it, I want you to remove those weeds, but leave those weeds and leave those crops, it can do that because it recognizes everything it's looking at, right? Or you can have it do any number of things. Like you can ask it, are there any pests in this field? And it can turn around and tell you, yes, there's a ladybug over there. There was some thrip under that leaf over there. And I know that because I can tell by the color changes in the leaf that leaf is under stress. And most likely running the statistics in the background, it's because there's thrip underneath that leaf. Like crazy stuff that as humans, you would need an agronomist to walk through the field and see that kind of stuff. AI, once it's trained, it can do all of that in milliseconds.
Troy, what about with soil testing? Is the machine deciding where to take soil tests, or do you put that in before? How does that all work? How do you go about programming and telling this thing to do it?
Nope, the customer decides where the machine goes, and then we have to put a sampling pattern over top of that because a customer is used to where a four-wheeler parks, for example, and then the Joe or Sally would get off a four-wheeler and take cores. And so we basically create missions, and it's predetermined until you hit real life and you find out that sample spot was on a washout or something. You just got to move off the side and put it in an ergonomically good spot.
I was going to say, you could tell it to go back, we're going to do soil samples here every time, or we could set it up that we're going to do grids, we're going to do it based on soil type, whatever the case may be, but you can input that and there's repeatability and it'll do that as long as you want it. All right. Craig, what do you think about the AI way of doing things and getting machines to do to solve a problem that we're trying to address?
Yeah, I guess in our company, there's many aspects of the system. The path that we take, that the tractor, when it goes to the field, the path it takes, that is programmatic, meaning that we tell it, this is the path you're going to take. Now, while it's out there operating, we use AI to monitor certain things on the implement and monitor things of the environment. So if we see obstacles or something that doesn't look right, and as Brent had mentioned, we take thousands and thousands of images, and it all comes down to how do you categorize them and how you classify them. And then it's just a training process where you have this bare algorithm, and you give it known data, and what it does is it learns. Like you said, that's a table, that's a chair, that's a man, and that's a wall. We actually go through and do the same process.
So you talked about the ability to monitor itself while it's doing the operation.
Yes.
What is it monitoring? Tractor function, work done? What is it? Tracking?
Well, it's monitoring multiple things, but we do monitor the health of the tractor. That is not through AI. We just monitor engine temperature and oil pressure and whatnot. But we're also, and it's being computed on the edge. We monitor the actual perception of the environment. Did somebody run out in front of the tractor? Are there any obstacles unforeseen that happens to be in front of the tractor? And we're also monitoring the implement as well, monitoring the health of the implement, and making sure that there's no anomalies.
Yes. Switch up. Okay. Give it a shot.
We good? Okay. So I'll just give you an example that we had. So the first field that we planted last spring with our planter, we actually walked behind our planter to keep a close eye on it to make sure everything was working good. So we get a lot of questions from farmers. How do you, okay, I'm going to drop this planter off or two planters off. How do I know that it's actually doing a good job or if there's not a problem? So the first field we planted, we got corn stalks caught in the closing wheels and it started plowing. Well, we were there after a few feet, stop, fix this. So a farmer, they want to know if a problem like that happens. You don't want it plowing all day long. So we haven't implemented anything yet relative to this, but it's another example of using cameras and AI. So you recognize that, okay, there's a problem here. Either the closing wheels aren't turning or it's, plowing or whatever, and you can recognize that. And then the question is, well, what do you do about it? Well, you probably stop the machine, you alert somebody. Maybe there's ultimately some autonomous ways to fix problems, but we're early stages. We haven't figured all that out yet, but we know we have to figure that out.
Are there any questions from the crowd? Anything? Tom, yes.
Just like when you think about autonomy, you think of 24/7 operation. Probably what we're going to have, like docking stations, fueling seeds, like that.
So the question is, you think of autonomy and the ability perhaps to do this, to have the machine run continuously, right? So what would it take to help do that? Do you have docking stations or the recharge and things like that? Is that the essence of the question, Tom? Yeah. Anybody on the panel want to take that on?
Yeah, I'll start with that. So we have run the first time we actually ran, all night long. It was 37 hours straight. We did stop it to fuel it up, but to your point, running 24 hours, there's going to have to be some sort of tendering that is done autonomously. So I envision, when we started out, and one of the reasons why we went with smaller tractors, it all came down to this. We had this vision that someone drops off a tractor in a 160-acre field, and 24 hours later, they drop it off at 7 in the morning. 7 in the morning the next day, they come out and they move it to another field. And when we were sizing our equipment, we were looking at what would it take to perform a field operation in, perform 160 acres in 24 hours. And it turns out, what's that? Right around 6.5 acres per hour, 10 foot, 6.5 mile an hour. There you go. And then we started looking at 60 and 90 horsepower tractors to do that. Now we fully realized when we did that carrying that much seed is much difficult, and carrying that much fuel is as well. So our whole intent was we're going to figure that out later, but let's just go down this path, and it's very economical as well in terms of doing that. That was our mindset. Running at 24 hours, I will say it is pretty, it's kind of a defining moment to lie in bed at 10, 11 o'clock at night, pull your phone out and see this little tractor just toiling away in the field.
Do you have a thought on that?
So our plan is to build a docking station for refilling, seed in the case of the planter. We will be spraying and side dressing nitrogen, so refilling chemicals, fertilizer. We've got certain pieces of that we're working on. We don't have the fully autonomous docking station yet, but the plan is to actually have that in place. And our vision is to have a docking station that's mobile across the into the field as well to help with speeding up the process, minimizing downtime basically.
I think this is on, yeah. So just a shout out to another company called Gus Automation, which makes autonomous orchard sprayers. What I've heard from them, and this is really a conversation around electric versus internal combustion engines, but what they run their vehicles on diesel, and what they found is because the vehicle is autonomous, they actually timed how long it takes to refuel those vehicles, and what they found is it was something like 1/10 of the amount of time that it took on a normal orchard spraying situation, because the driver comes up, refuels the vehicle, and there's nobody to talk to. He can't shoot the breeze with the tractor driver, so it's just dead boring. So he refuels it, gets back in his truck, and takes off. Whereas before, they were having a really good time catching up on the game and everything else, and that doesn't happen anymore. So,
Pretty interesting. Thoughts?
I promise you I am a visionary. I'm an optimistic person by default. But I do have a contrarian point of view. And
Please.
I think when a farmer is considering whether he's going to buy an autonomous package for his farmers, I don't think he's going to care. His first questions are not going to be, how does it work with the docking station? How do I fill this thing up with fuel? How do I fill this thing up with seed? It is going to be a whole host of other questions on how it truly is going to be an easy button. And now I'm not up here acting like I'm the expert in how these things are going to happen. I think what Craig and all these guys are doing is more advanced in a lot of ways than what I'm doing. But as I think our farm in northeastern Indiana, we have been successful because we are dead nuts on being logistically efficient, and we work hard, and that's how we think about things. We're not the greatest agronomists in the world. We're not the greatest at a lot of things. We work really hard, and we're really good logistically. And I think farmers are going to be thinking about how do we I think they're going to be thinking about what places are they going to put autonomy that have the lowest consequences when something goes wrong. So that's why I don't think planters will be the first places. I think it'll be tillage tools like what Craig's working on, and like, well, if it messes up, who cares? We'll go redo it. Or I think farmers will be like, what's a consequence when something does wrong, and how easy is this? And I'm not even so sure that 24/7 is going to happen right away yet, because when something's out there running, there's a stress that's happening. I'm not just going to go to bed that easy unless I have 4 or 5 years of experience that nothing has ever gone wrong.
And if you're dead nuts, you'll go to bed at that point too, right? You know?
Think of my dryer. When my dryer is running, drying corn, I am still not getting as much sleep, and that's a very simple piece of machinery.
I'm going to come to your question in just a second, but it kind of relates to this. I wanted to ask if and when we go down that way, what sort of support structure is there going to have to be on the farm? You know what I mean? Docking stations, broadband, cellular capability. What is it going to take for a farmer to buy that piece of equipment and put it to work?
So I would say one of the key pieces to this is teleoperation, right? Which is when that vehicle is moving through the field and it sees a squirrel or it sees, a piece of equipment that somebody left in the field or whatever, and it stops, it needs someone to dial in and tell it what to do. And that may be, you're gonna have to change your path and go around that, or just never mind, just roll right on over it, or whatever. But it has to have some kind of human intervention, and that's not gonna change. But that human can also be looking over 10, 15, 20 different pieces of equipment, right? So, but there's still gonna have to be human eyes on what's going on until we reach a point with the AI where the AI literally just recognizes everything and it automatically knows what to do because it's already been told what to do in those circumstances.
Okay. Any other thoughts? What is it going to take for a support structure to put this equipment to work? Any other thoughts?
We're going to have to think about how to move these things around from field to field. I think the support structure, I mean, as a farmer, if John Deere came to me and said, hey, we bought Sabanto and we're going to offer you this package, I'd be like, great. How are we going to transport these tractors from field to field? Me and my brothers would get in a room and be like, how's this logistically going to work out? How are we going to transport the tractors? What happens when there's a problem? How do we remediate it? Is it like a 10-minute Ranger drive every time we have a problem? Or are we going to have enough problems that we're just going to hang out in the field anyway until it's done? And like, well, I don't put my brother Darren in the planter because he can drive the tractor the best. So it's just all those questions will be going through. It's a different game for me. So I'm rooting. I'm truly, obviously, I'm rooting for this.
Yeah.
I've just been beat up a lot, and I want to solve the right problems in the right order.
Well, let's be fair about this. Some of these things have been going on for a while, but this is a very young industry, right? We're still in the early adoption stage. There's a long way to go on some of these things, right? Sir, you had a question. What question do you have?
An observation first. There's only 20 people in this session, which is crazy. But second, when replacing labor on farm, talk about how hard it is to attract the labor to actually make the AI and the autonomous and the programming side. How are you guys finding that talent that is competed for in lots of industries to bring it back?
Okay, so the question that he asked is, heard about labor, getting labor on the farm. What about the labor in your companies? What does it take to weld things, put things together, software programming, things like that? Thoughts?
Yeah, I can tell you one thing. It's a hell of a lot easier for me to go find a data scientist who understands AI than for me to go find a capable, knowledgeable, dependable young person that understands precision agriculture and will work for me.
Any other thoughts?
Talent is difficult to find. We're relatively small companies, so we don't have a lot of people yet, and we have a little bit of an advantage in that we're based in Ames, so we have nearby source of some talent in terms of software and those sorts of skills.
You're talking about University of Iowa, right?
Cyclone country, Chad.
So I think this isn't going to help the whole, ageism perspective, right? Because unfortunately, you don't have a lot of 50-year-olds rolling around with data scientist credentials and software engineering credentials. So the truth is, you gotta chew earlier and earlier up the career path until you're doing, arrangements with a lot of these schools, with AI labs at school, so you can start to grab those graduates that are coming out. And what I've found is a lot of it is you're selling them on the mission, right? So you're telling them, yes, you can go to work for Meta or you can go to work for Google, and you can put your talents to work getting better advertising in front of the eyeballs of all those humans that don't really want to see your advertising. You could do that, or you could help feed the planet. Your choice. Where do you want to go? And it turns out that a lot of people are compelled to help feed the planet. So I'm not saying that it's easy, but I am saying that what Craig's point is totally valid, which is you get a lot of companies that are full of technologists, and they're looking for, we're super smart, we can solve any problem. Where's a good place to solve? Agriculture, let's do that. And they're coming out of Seattle, they're coming out of, San Francisco, and they don't know anything about the dirt, right? So they roll their solutions into the fields, and this stuff is fragile, it's breaking down. The growers are like, get that crap out of my field. Like, oh my gosh, I've got a plant today. It's very hard to find the opposite of that, which are the agriculturally intelligent individuals who know the land, who know the field, and who are willing to jump the gap into the technology side, because today that doesn't exist in the schools. You've got the agricultural curriculum, and then you've got the technology curriculum, and they're not playing together. They don't see each other. So there has to be a bridge built there between those two practices. Sooner or later, somehow, it's going to have to be all of us that are kind of encouraging that, because the schools, there are so many schools today that have agricultural curriculums, but they don't have any kind of AI curriculums. They don't even have anybody to teach it. So we've got to solve that issue.
There were about 275 kids from across Nebraska here. I think we just missed them. That would have been a great take-home, is get together with your schools and make what he's talking about happen. Unfortunately, real quick.
I want to add one thing.
Yep.
Whenever I meet with colleges and their Department of Agronomy, I cannot believe that agronomists don't learn programming at all. I mean, and every farmer I meet, they program in Excel, and every agronomist I meet programs in Excel. I can't believe that they don't teach them Python or some software.
If you've got an in, make the suggestion, right? We're getting close to the end of our program here. We've got a couple of questions I want to toss at you guys. One of those is, this equipment, the concept, the idea, that's one thing, right? Do you think autonomous equipment, is this an old enough industry or an old enough concept that we understand return on investment for either the agribusiness or the farmer yet? If so, do we have an idea of where that might be? Any thoughts on that?
So I'm going to play the contrarian here. I know in the weeding space there have been 2 or 3 companies already that started with autonomous weeding machines, and then they stepped back to tractor pulled implements because they literally just couldn't make the RO work on, the implement takes 25, 30 people out of the field. The autonomous tractor takes 1 person out of the cab. How do you make that pay out? So I know that there's no question in my mind that everything is going to go autonomous. It's how we get there, and when the sensor suites drop in price enough that it makes sense, and the OEMs are going to go that direction, and Sabanto is going to help carry it all there. But I think we're a ways off.
Wow, big job. Any other thoughts on kind of where we sit with ROI or the potential?
I think it's really exciting that we get to solve problems in the ag industry because we're working in a very skeptical industry. Farmers are skeptical, they're fast, they're hardworking, they're smart, they have a high bull crap meter, and I think they've been frustrated by startup companies coming in and seeing, hey, this is something the size of the microwave, we're going to plant your field with it. Oh, and by the way, we're electric and we have solar panel. Like, no one cares about that crap. No one cares. We want to get the job done. We have 2 weeks to get our corn planted, and you're going to tell me how we got to get that done. And I'm enthused by that attitude in ag. And I think in other industries, I think you can spend more time spinning your wheels because people aren't telling you the truth fast enough.
So the one thing I wanted to add about that, number one, going with smaller equipment, obviously your ROI goes down. And we're seeing greater than a half on a per acre cost. And I've always said that I think if you look at any acre that's been commercially farmed, I can't imagine anyone out there is doing it less per acre than what we are. So the other thing too, and why ROI is hard to compute quantitatively. And I give the example, we're working with a fairly large enterprise, and we took one of their tractors, made it autonomous, and we were performing field operations. And they had 19 other systems running. Okay, we, in our autonomous system, we are not allowed to turn tighter than a given radius. We have a turning radius, and it will not turn tighter than that, because we programmed it for that. Currently, at the one time, they had 7 systems sitting off to the side. Again, the people driving it, these laborers that they get, they turn too sharp, ruin the PTO, systems sitting in the field, waiting to get repaired. So, I mean, the system does what it's told, and it doesn't cheat because they have a hot date on a Friday night, and they turn a given radius and whatnot.
So there's a certain amount of confidence in that.
Absolutely.
Yeah. All right. Unfortunately, we came to the end of our time here. I went from this way down to the beginning. I'm going to start on the far end and work my way this way. Final thoughts, for the crowd that's here, what is one takeaway about utilizing autonomous technology in agriculture? What's one thing that you want this group to take away from today's discussion? Make sure they remember.
Don't be afraid of AI. It's not coming for you. It's going to help us do our jobs better. It's going to lower our costs, lower our inputs. I think everyone here should be leaning in as much as they can to understand it better so that they're not scared of it, because the media runs all these sensational garbage articles about it's going to take over our lives and the robots are coming. Yeah, that's just total crap. Like, don't buy into that. Just, don't buy into that.
So, can I amend your comments by saying some media, not all media?
Not all media. Yeah, whatever.
Craig, how about you? What's a take? And you can't duplicate, by the way, from that end to this end. What's one takeaway?
When I started this company, I had 2 principles. Number one, I don't think autonomy is an all or nothing proposition, meaning that there are some field operations that will still have to be done manually, or when I say manually, someone is going to be sitting in the seat on a tractor, and that's primarily one of the reasons why I think your next autonomous tractor or your autonomous system will still have a seat and a steering wheel. The second thing is autonomy is a technology, and I've always been a technologist for most of my life. I've been a CTO at companies before, and I've always been enthralled with and think technology is the greatest thing in the world. But I think the real change that's going to come down is how autonomy is going to change the business model in agriculture. Set the technology aside, you're going to start seeing some very interesting business models in agriculture, all based off autonomy.
Pretty exciting coming down the line. Troy, what do you think? What's one takeaway?
One thing I would like to encourage the industry is to. I think we need to make sure we're being very kind to each other. There's a lack of people like Dave and Craig and Brent out there that's really getting out there and trying to sometimes be on the bleeding edge of technology, and that can be a very difficult place to be. But I also think sometimes there's a lack of. Sometimes farmers can have a bad attitude, you know, for maybe good reasons, but maybe it's not delivered in the right way. It can be discouraging. For example, I've been really thankful for our earlier customers who have given us a lot of grace. Whenever, you know, they're like, hey, we're going to take a chance on you, but you got to get the job done. And there's been times I have failed people. Like I promised a 3-day turnaround time to get your soil samples done, and if something broke down and I couldn't fix it, and it ended up being longer than that. And I really appreciated that grace. And if they didn't have to do that, but if they didn't do that, I probably wouldn't be here today, still trying to solve this problem. So I think we need to be encouraging yet remain skeptical, so that we can get to the solutions faster and more efficiently, so we don't have burnout from the people that are trying to solve the problems.
Skepticism and kindness sometimes doesn't go together. That's okay though. That's good. Okay, Dave, you get the final word. What's a takeaway that you want these people to remember?
Yeah, first of all, I agree with everything these guys just said, but you know, I get the question, is autonomy coming? Absolutely it's coming. I think machine learning and AI is going to be a part of it. I think we're still trying to figure out a lot of things, and there's a lot of unanswered questions. In terms of business model, where does the business model go? In terms of a lot of things, we just have a lot of things to figure out. And you know, as a startup, that's what you live for, figuring things out. And so we'll keep working at it.
All right. Pardon, are all four of you guys over in the Innovation Hub? Yes? Okay, good. So if you had a question that you didn't get answered, these guys are going to be here. The Innovation Hub over on the other end of this building has got, what, 50 exhibitors or something like that? These guys are a part of it as well. So interact with these guys, pick their brains, ask questions, challenge them. They'll be around to do that. So again, thank you guys for being here. Again, Dave Krog from Salin 24/7, Troy Fletcher from Rogo Ag, Craig Rupp from Sabanto Ag, and Brent Shed from Stout Ag. Let's give these panelists a big round of applause, would you please? Thank you, gentlemen. Appreciate your time. Thank you for being here. We're going to take a break. We have another session coming up here in about